Okay, so next example, we have a region lying in the first quadrant bounded by the circle and the line. Okay, so the circle that we have is given by x minus 1 squared plus y squared equal to 1. And also we have a line y equal to 0 is x-axis. So what is the graph looks like? So on y-axis plane, so let's say this is 1 and this is 2 and this is 1, this is minus 1. So we have the circle with radius 1 where the center is at 1, 0. So that is the circle that we have. Okay. And then because of we want the region only lying on the first quadrant, so then we have to eliminate this one. Okay. So now we have the region bounded by the circle and the x-axis. So the region that we have is lying inside here. Okay, so now we are going to evaluate the area. So using the double integral to get the area, using double integral, we have 1 dA over the region R on y-axis plane. So since the region is part of the circle, so it looks like it's more easier for us to solve this using polar coordinate system. So then r dA is r, dr d theta. So now you need to determine the angle. So as you can see here, the angle here because of the region here lying inside the first quadrant. So the first quadrant should be 0 to pi over 2, right? So 0 to pi over 2. And then to determine the r, you have to draw a line starting at the origin. As you can see that the smallest r, because the region is passing through the origin, so meaning that the smallest r is 0 and the highest r is lying along this curve in polar, because we know this equation in Cartesian, but what is the equation in polar? Okay, if you remember the graph that I mentioned before about the rose petal, so this one is actually given by r equal to 2 cos theta. Okay, but maybe you have forgotten about the polar graph, but you have to know, okay? So in case you don't remember that, you can use the equation in Cartesian and convert into polar, where the same as you done for 2 sin theta previously, where you need to expand. So you from here you have x squared plus 1 minus 2x plus y squared equal to 1. Then you can have x squared plus y squared minus 2x equal to 0. Then from here you can convert into polar, where we know that x squared plus y squared is r squared. So r squared minus 2r cos theta equal to 0. And then factorize r minus 2 cos theta equal to 0. Then you can have r equal to 0 and r equal to 2 cos theta. So r0 we know that should be the origin, so which is not telling you the whole graph for this. So this one is supposed to be 2 cos theta, which is this one. Okay, if you remember the equation directly, you can use, or if you don't remember, then you just convert using the formula from Cartesian to polar. Okay, so now we know that the upper bound of the r is part of the circle. In polar, we have 2 cos theta. 2 cos theta. Okay, so now we substitute the limit r 0 to 2 cos theta. Okay, so next, then we can proceed to evaluate. So when you evaluate that, you have 1 over 2 r square 0 to 2 cos theta d theta. Then this will give you 1 over 2 4 cos square theta minus 0 d theta. Then we can simplify. You have 2 cos square theta d theta, and again you need to reduce the power here by using identity of trigo. So you need the you need to replace this one. You have to use this, okay? So meaning that you have to use cos. I'm sure that you cannot see that clearly. So you use a cos 2 theta equal to 2 cos square theta minus 1. So you have the 2 cos square theta equal to cos 2 theta plus 1. Okay, so now cos 2 theta plus 1 d theta. So you can't see the square anymore, just cos 2 theta. Then you can directly integrate. You have sine 2 theta over 2 plus theta. So theta from 0 to pi over 2. So you have sine, so 1 over 2 sine pi plus pi over 2 minus 0. So sine, so we will get 0 here, so we will get pi over 2. Okay, so you might wonder, maybe some of you wonder, how can we know that the angle that we have is from 0? So it's clearly seen that the graph, the region here touch the x-axis, so the smallest theta should be 0. But how can we know that the highest theta should be pi over 2? So the same idea that we done from the rose petal before this, where we can equate, instead of r equal to 2 cos theta, which is given by the circle, and we can also another r, which is r equal to 0, as we can see that the region here is inside the region here there is also the origin. Those mean that the origin also part of the region, so we can have r equal to 0. So then you can solve simultaneously between the r 2 cos theta and r equal to 0. So when you solve simultaneously, you can have this one, and then we solve for theta, so we have arc cos 0. So now what cos then will give you 0? So based on the graph, or maybe you will just use the calculator, right? Because I don't like to use the calculator, so I just use the graph of cos for one cycle, so 0 to 2 pi. So from the graph you can see that to get 0, so the theta is where we can have pi over 2 and 3 pi over 2. But since from the our region here is only lying on the first quadrant, which is not more than 90, so based on the result here, we only considered pi over 2. So meaning that 3 pi over 2 is excluded because that one is out of the region. So we know that the theta here, which satisfy the r2 cos theta and r0 is 90 degrees. So that's why here we put the 90 degree or pi over 2. Okay, so that is another way that you can try, or you can just look at from the region itself. Okay, about determine the angle. Okay, so look at the example for finding volume using polar coordinate system. So here the solid that we have is, we have the solid below the cone and above the above the XY plane. But then inside the cylinder, oh, so now there are so many surfaces that you have to sketch. Okay, so firstly, so this is firstly you have to know, or you have to have the solid. Okay, so in this case your solid is part of the cone, and z equal to square root of x squared plus y squared, and then you have the xy plane. So xy plane, we have, meaning that we have z equal to 0. Okay, and then we have the cylinder, x squared plus y squared equal to 4. Okay, so we have a cone. Okay, just to get an idea. Okay, we have a cone, concave up. So this one still considered open. And we have a cylinder. So we have a cylinder parallel to Z. And the cylinder is coming from the circle with radius 2. Okay. And then xy plane, Z equal to 0. So that is Z equal to 0, xy plane. Okay. So so now you have to combine them all together, because you have to have a single solid which is bounded by all these surfaces. Okay, so let's see. I put the cylinder. Okay, I put the cone. So let's say I put this cone into the cylinder. So we know the size of the cylinder here, which is part of the circle with radius 2. So that I choose a different color. So that is part of the cone. Okay, so that is the cone. Am I right? Okay. Okay, so I think I should redraw properly. Okay, so I have the cylinder. I have so this is it. And then I have a cone, and I have the cone. So that is the cone. Okay. So now based on the instruction here, we have a solid below the cone. So the solid should be below the cone, down here, somewhere here, above the xy plane. So this is the xy plane, which is z equal to 0. So this one is z equal to 0, xy plane. And inside the cylinder, which means that that is your solid. Okay, so then it looks like we have to eliminate this part, right? We don't need that. Okay, so that is the solid that you have to evaluate the volume. Okay, so now this is not something easy. Okay, you have to. Okay, so here formula. Okay, the formula to get the volume using double integral, where okay, so your function is it in terms of xy, and then dA over xy, where your region over xy, is that so? Okay, so now look at your sketching here. So you have this particular orientation where I have x and y. Okay, So meaning that I mean you will standing like this way, right? In the or this way, isn't it? So you are on your region are lying on XY plane. Okay, so then that's why we put the XY here, and your function here should be in terms of only X and Y. On your and your order of integration should be only dx dy or dy dx. Okay, so now how can we determine the function? So as mentioned before, you have to determine the function first. So to determine the integrand or the function here, you have to look at your solid. If you're standing like this, okay, and you have to determine your lower bound and your upper bound, your lower bound and your upper bound. So then how can you read this function? Is it x equal to, is it y equal to, or z equal to? So how can you know that? So now look at your region like lying on xy. So all the variable are only x and y. So what else? What is another variable is not here? Z, right? So meaning that the f here, the f here should be belongs to z. Okay, which is the upper bound of z and the lower bound of z, which is u. Z is now you yourself. So now from your sketching from the solid here on 3D, so determine what is your lower bound. Okay, who is your floor now? So your floor is z equal to 0. So now we know that z1 is 0, which is z equal to 0. And then your upper bound, okay, upper bound, who is covering you? So your roof or your cover here is part of the cone, right? The cone. So what is the equation of the cone? The equation of the cone is given by square root of x squared plus y squared. So here you have square root of x squared plus y squared. So then you can see that your function now is given by z2 minus z1. So z2 is square root of x squared plus y squared, and your z1 is 0. So now your f is square root of. So now you already obtain your integrand is the square root of x squared plus y squared. Okay. Okay, so now look at your region. So what is your region looks like? What can you see on the xy plane? Which means that what is the dominant shape that you can see when you are standing along the z and looking down? So you can see the circle with radius 2, right? So you can see the complete circle with radius 2. The complete circle, okay? So you don't see on the xy plane you don't see the cone anymore. The dominant one is this circle with radius 2. So since the region that we have is a circle, so then we want to solve this using polar. Okay, so you have to convert everything in polar. So now your integrand becomes just r, and then dA is r dr d theta. Okay, so now determine to determine the limit here, you just look at the region. Okay, so to determine the integrand, you have to look at the solid. So that is the thing that you have to know. Don't mix up everything. So when you need to use the solid, the information from the solid that you sketch, only to determine the integrand here. But to determine the order or the limit of integration, you just need to look at the region that you have. Okay, that's it. Don't mix up everything. So then from the region that you have, so we can know the limit of r and the limit of theta. So the theta, because you have a complete circle, so your theta is 0 to 2 pi. I mean that the whole quadrant, from the quadrant 1 to the quadrant 4. So your theta should be 0 to 360 degree or 2 pi. And then your R is 0 to 2. Okay, how can we know the 0 to 2? So we just draw a line for any quadrant. So they are all starting from 0, starting from the origin, and end up along this circle with radius 2. So that's why we have R2. So then we substitute the theta is 0 to 2 pi, and the R is 0 to 2. So then we can evaluate that. So we have R square. So 1 over 3 R cube 0 to 2 d theta. So we have 8 over 3 d theta and 8 over 3 theta 0 to pi and 8 over 3 to pi. So we have 16 over 3 pi unit cube because we are computing the volume. Okay, so these are some example to get the area and volume using polar and also Cartesian coordinate system. Okay, so for this one, I will skip this after we done the triple integral. Okay, I will get back about this application after we done the triple integral. Okay.